Hey guys, we're now looking at target 2.7. And it says I can solve real world problems involving angle of elevation and angle of depression. So we'll look at what those are, and then by using a trigonometric equation. So we're doing more solving with trigonometric equations, just like we've done the past few days. Alright, but now it's just going to be word problems. The word problems will always tell you if you're looking at an angle of elevation or if you're looking at an angle of depression. So an angle of elevation is sorry, the line of sight up from a horizontal line. Okay. So for here, right, I have a horizontal line, and my line of sight goes up to this line of sight. Or sorry, my angle of elevation goes up to that line of sight. Okay. For an angle of depression, right, it's the line of sight down from a horizontal line. So same type of thing, right? We have a horizontal line, and then we're going down from there, okay? The biggest thing is it's this horizontal line, okay? The biggest mistake I see is a lot of times we have like a fake triangle on the bottom, and students will put like the angle of depression here. That is incorrect, okay? Because that's between the line of sight and the vertical line. So make sure you're going to that horizontal line with both your angle of elevation and angle of depression. Okay. So example 1, identify the angles of elevation and then the angles of depression. So if I look at number 1, right, here's my horizontal line, and it goes down. So 1 is an angle of depression. Number 2, here's my horizontal line, and that line of sight goes up from there. So number 2 is a line of an angle of elevation. Number 3, using that same horizontal line, it's going down from there. Is an angle of depression. And number 4, here's my line, and it's going up. So that is an angle of elevation. So elevation goes up, depression goes down. So most of the times we'll have to draw our own pictures for these word problems, but then once you have the picture drawn, it's exactly what we've been doing for the past 3 days. If you have a good picture, you should just be able to solve. The angle of elevation from a cooker's foot on the football field to the top of the goalpost bars is 17 degrees. Okay? So anytime we have an angle of elevation, I'm going to draw a triangle this way. So the angle of elevation is 17 degrees. He is standing 131 feet from the base. Right? Again, remember, base means bottom. So the bottom is 131 feet. How tall is the goalpost? So I'm always going to put an X with what I'm solving for. All right, so then Now I'm just solving this like I would any other problem. Here's my angle, my opposite side, my adjacent side, and the hypotenuse. If we look here, the hypotenuse is unimportant. I'm going to be using my opposite side and my adjacent side. Using the opposite side and the adjacent side, I'll be using tangent, right? So the tangent of theta equals O over A. So then tangent of 17 equals x over 131. I'm solving for a side, and when I solve for a side, I automatically put it over 1 and cross multiply. So we get 131 times the tangent of 17 equals x. X is already by itself. I don't have to do that division step. If we type that in our calculator, we get 131 times, under our trig menu, tangent of 17. We get about, we'll round it to 40. That's fine. So we have 40 feet there. So again, once we have that picture set up, it's exactly the same as what we've been doing. Let's look at example 3. Leah's mom is standing at the bottom of the slide at a playground waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees, and the slide has a vertical height of 9 feet, find the length of the slide. Okay. So again, angle of elevation, there's the words I was looking for, means my triangle should be going up. So we draw a triangle like this. Okay. And that angle is 46 degrees. And the slide has a vertical height of 9. Find the length of the slide. This is where it kind of gets difficult, is thinking about what that is. If I'm actually sliding down the length of the slide, right, I climb up the ladder, and then I slide down here. That's where my x is. Okay, a lot of people want to put that length here. But that is not correct. Okay. So then, labeling my sides, we have our opposite side, our adjacent side, and the hypotenuse. In this case, my adjacent side is unimportant, meaning I'm using my opposite side and my hypotenuse. If I'm setting up a trig equation with the opposite side and the hypotenuse, then I'm going to use sine of theta equals O over H. So sine of 46 degrees equals 9 over x. Again, solving for a side, I'm immediately putting it over 1. So I have x times the sine of 46 degrees equals 9. Okay, in this case, my x is not by itself yet, so I have to divide. Those cancel, so x equals, and I'm just typing that in my calculator. 9 divided by the sine of 46. And we'll say it's about 0.5, is this also in feet? Yep, 12.5 feet. Okay, so the length of that slide is about 12.5 feet. Alright, let's go ahead and turn to the next page, look at a few more examples. A dog is standing 5 feet from the base of a tree looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? Okay. So yeah, we have a dog standing on the ground, so again, it's an angle of elevation problem. So a dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet. So our dog is 5 feet from the base. Again, that word base means bottom. And the cat has climbed 16 feet up. And it's asking us what the angle is. So we're going to put our X where our angle of elevation would go. Okay. Now, solving this problem the same way. Here's my opposite side, my adjacent side, and the hypotenuse. Hypotenuse is unimportant, meaning we're going to look at tangent. So the tangent of theta equals O over A. So we'll do the tangent of X equals 16 over 5. And now we're going to do the inverse tangent, right? Get rid of that tangent of X, we do the inverse tangent of the tangent of X. Equals the inverse tangent of 16 fifths, not just 16. So our tangents cancel, and we're left with X equals, and I'm going to type that in my calculator. Right, the inverse tangent of 16 divided by 5, and we're going to round it to about 73 degrees. All right, looking at example 5, we're now going to be looking at an angle of depression problem. Okay? A lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? Okay? So this is an angle of depression problem. And really the angle of depression problems, we have to switch our triangle. Okay? We're now looking down instead of looking up. Okay, so for angle of depression problems, we're going to draw a triangle like this. Okay? And it says the lifeguard's line of sight is 8 feet above the water. So that's 8 feet and going up. And that's because really our lifeguard is sitting over here. But if I think about this height and this height, they're the same height. Okay, so it's 8 feet up. And the angle of depression is 18 degrees. How far away is the swimmer from the lifeguard? Well, here's my lifeguard, here's my swimmer, so my X is going to go there. So then I have my opposite side, adjacent side, and the hypotenuse. The adjacent side is unimportant. So then we are going to have opposite and hypotenuse, which is sine. So the sine of 18 degrees equals 8 over X. I'm solving for a side, so I'm immediately going to put it over 1 and cross multiply. So I have X times the sine of 18 equals 8. And then, right, I have to divide. These cancel. Divided by the sine of 18. And we get, we'll round, X equals 26. Usually in like a test or a quiz, I'll give you what to round to, so you want to decide. but x is about 26 feet. All right, looking at example 6. A pilot in a helicopter spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? So again, we're doing angle of depression. So I'm going to draw our right triangle like this. And the angle of depression is 73 degrees. The horizontal distance is 1,200. So this is horizontal. Altitude is just another word for height. Right? So I talk about like planes have an altitude, whatever. Okay, so the altitude, if it ever asks for altitude, is just a fancy word for height. So again, here's my angle. We have our opposite, our adjacent, and the hypotenuse. In this case, the hypotenuse is unimportant. So I want to use my opposite and my adjacent side. That means I'm going to be using tangent. So tangent of 73 equals x over 1,200. I'm solving for a side, so I'm putting it over 1 and cross multiplying. So 1,200 times the tangent of 73 equals x. X is already by itself, so I can just type this in my calculator. And I get 3,925. Alright, last example we're going to look at today, example 7. A building is 480 feet tall. Sally is on the roof looking down at a penny on the ground at an angle of depression of 42 degrees. How far is the penny from the base of the building? Okay. So again, this is an angle of depression problem. A building is 480 feet tall. Our angle of depression is 42 degrees. How far is the penny from the base of the building? Well, again, base always means bottom, so it'd be like this distance, but this distance is going to be, thank you. So I put an X here, but this distance and this distance are the same. Okay? So some of these times with these angle of depression problems, you put the variable in an equal spot instead of like the spot it's supposed to be because of where that angle has to go. Now we can set up our problem. Here's my opposite side, my adjacent side, and the hypotenuse. The hypotenuse is unimportant. Using opposite and adjacent is tangent. So the tangent of 42 degrees equals 480 over x. We are solving for a side, put it over 1. X times the tangent of 42 equals 480. I'm going to divide by the tangent of 42. And then 480 divided by the tangent of 42 is 533 feet. All right, that is it for word problems for today. I'll see you guys tomorrow.